Hello everyone, we have a question here on the board. This is a physics question on Hooke's law. It says a mass of 11 kg is suspended from a rigid support by an aluminium wire of length 2 meters, diameter 2 millimeters, and Young's modulus 7.0 times 10 raised by 11 Newton per meter squared. Determine the extension produced. Okay, first thing first, what is the formula for Young modulus? And Young modulus is simply, let me use this sign for Young modulus, is simply stress divided by strain. And as we know, stress, when you say you apply stress on a material, it means that you are applying pressure. So stress has the same formula as pressure. And what's the formula for pressure? Force divided by area. So we have it as force over area. Then we have strain as the extension over the original length. So that therefore Young modulus will give me force over area divided by the extension over length, right? And I need to change this to multiplication sign. So therefore my Young modulus will be force over area times length over extension. So I'll have my Young modulus will be force times length over area times extension. And for this particular question, what am I looking for? I'm looking for the extension produced in the aluminium wire. So I'll just have to make the extension the subject of the formula. If I make extension the subject of the formula, in this case, I'll have that the extension produced will give me my force times my length divided by my Young modulus times my area. Okay, now we've gotten the formula we can use to solve this question, but we need to be very critical about this question. In bringing out our data, remember the length is 2 meters. The mass is 11 kilogram. And what else? Diameter. Take note of this diameter. 2 millimeters. So we need to convert this to meters. But what was given was mass. And what was asked is force. And what's the formula for force? We have force to be mass times acceleration. And in this case, since we are talking about Hooke's law, we will take our acceleration due to gravity to be 10 meter per second square. In the exam condition, you see something like this: G is equals to 10 meter per second square. Okay, after adding that, now we have that the extension produced will be force, which is mass times acceleration, which will give me 11 times 10 multiplied by the length in the aluminum wire, which is 2, divided by my Young modulus, which is 7 times 10 raised to the power of 11. Okay, now multiplied by my area. The area was not given, but the diameter was given. Okay, if you can recall, the area of a wire altogether is pi r squared, right? And radius is the same thing as diameter over 2 squared. So I'll be having that pi d squared over 4, right? Okay, let's just quickly solve for the area so I can put in the values here, okay? So we have that the area will be the pi, which is 22 over 7 times the square of the diameter. The diameter now is giving us 2 millimeter. Changing millimeter to meters, we need to divide by 1000, which will give me 0.002 meters. But we have to square it because it's diameter squared over 4. Now, solving this, let me punch it in the calculator to get the area of the wire. So we have that pi, which is 22 over 7, multiplied by 0.002 squared divided by 4. I'm left with 3.14 times 10 raised to the power minus 6. I have it as 3.14 times 10 raised to the power minus 6 meters squared, because we are talking about the area. So I'll have to plug this here in the formula. So plugging it, I'll have that times 3.14 times 10 raised to the power minus 6. Okay, so therefore the extension produced would be, we have 11, which is the mass, times the acceleration due to gravity, times the 2, which is the length, divided by the denominator, 10 times 10 raised to the power 11, times 3.14 times 10 raised to the power of minus 6. So doing that, I'll be having my answer to be 1.0 times 10 raised to the power minus 4 meters, right? 1.0 times 10 raised to the power minus 4 meters. And I believe this should give me, yeah, you can just leave our answer like this, or you can put your answer as 0.0001 is 1 2 3 4, yes, meters. So this is the extension produced in the aluminium wire. I hope this is clear for you, and for better understanding you can send me your questions concerning Hooke's law or anything in physics so we can treat it next time. Do not forget to like, share, and to subscribe. Thank you, and God bless you. Bye.